Okay. Little algebra 2 review. Y equals x squared. What does that graph look like?
It was like
Parabola. Where's the bottom of the parabola?
at the
Zero.
At 0, 0. At the origin, right? Okay, good. What would... Whoops. What would that do to the graph?
Shift it to the
Up.
left. Up.
Up 5. Yep. That plus 5 that happens after the x squared just takes all the y values and adds 5 to them. Well, if you're adding 5 to a y value, you're just moving every coordinate up 5 units, right? So this would move the graph up 5, but it would look exactly the same as this one, right?
Yeah.
It's just a shift. Translation, 5 units up. You're just lifting it up. If it was minus 5, down 5. You just take that whole parabola and move it down 5 units, right? Okay? How about this?
To the left. No, to the right.
To the
Because you
right.
think opposite.
it's the opposite.
It is opposite. Yep, it is opposite. You move it to the right 3 units. The reason being, what makes this equal 0? What would make this quantity equal 0?
3.
A positive 3. So a positive 3 is where the parabola hits 0, hits the bottom. Okay? So that moves it to the right 3 units. So inside, here's the big key. Okay? Inside the parentheses, shifts it left or right. Afterwards, shifts it up or down. Okay? We knew that, or hopefully we remember that a little bit from Algebra 2 in our translation of functions. So, if I start adding more to our trig functions here, we've already talked about how the A and the B affect our graph. Now I want to talk about how the C and the D will affect our graph. Okay. We know that the absolute value of A is our what? Amplitude. Good. We know that 2 pi divided by the B value is our period. Okay, we know those already. Let me start with the easy one, D. Okay. That number way back here at the end, or they could put it at the beginning, you know, they could put like 7 plus a sine or a cosine something, so I mean I don't want to say it's always at the end, but the one that's added or subtracted to the sine function, that is going to shift the graph up or down. It's going to change the midline, okay? So y equals d is the midline of the sine or cosine curve, or wave I'll call it, okay? Shifted up or down from the x-axis. Okay? So if you had a plus 5 at the tail end of the function y equals sine x and then plus 5, you know how the sine x generally just oscillates back and forth of the x-axis, right? It goes above the x-axis, below the x-axis, above the x-axis, below the x-axis. Now, it's going to do that at the line y equals 5. Okay? So it's like the line y equals 5 kind of becomes your new x-axis in a way. The graph will go above the 5 and below the 5, above the 5 and below the 5, and so on. There.
So there is a chance that it won't even cross it.
Yeah, you move it far enough away and the amplitude's not enough, the graph will never even get back to the x-axis. Correct. Okay? So, the d value, The D value is the vertical shift. It's the midline, the change in the midline. Okay, however you want to think of it. Good on the D value? Okay? Alright. Now, unfortunately, C is not itself just the shift left and right. Because there can sometimes be B values that affect it. This is in parentheses here. Okay? I'm going to take what's in parentheses and set it equal to 0. You know how I asked you, okay, where would the bottom of this parabola be?
Yeah.
Well, the way you could figure out how far it was shifted, you could set what's in the parentheses equal to 0, so x minus 3 equals 0, so x would equal positive 3, and if x is equal to positive 3, that means it moved it to the right 3 units. Okay? That will tell you the shift. Okay? In trig, if we set this equal to 0 here, b theta plus c, if we set that equal to 0 and solve for theta, so b theta would equal negative c, right? And then theta would equal negative c over b. The opposite of c over b, sometimes you'll hear me say. This right here, that is your, what they call phase shift. And really all it is a left or right translation. It's how far you shift it to the left or to the right. Okay? That is your left or right shift, depending on what you get for your opposite of C over B. Yes?
So your period's still 2 pi over b, and you don't touch that.
Correct. The period, not going to change at all.
And then when you get to the c value, that's phase shift.
That's going to shift it left or right. Yep. Okay? Make sure everybody has that written down. Everybody good there? Okay? Alright. So, y equals negative 3 cosine x over 4 minus pi plus 2. Okay? We're not going to graph this one yet. Okay? I just want to identify everything first. Okay? Amplitude.
3.
3. Why?
There's a 3. A value is 3.
It's the A value. It's the number being multiplied by the cosine. Okay? Amplitude 3. Period. How do we find it?
Pi over 2.
What?
2 pi.
2 pi
Over b.
over b. Okay? 2 pi divided by the b value, which Drew's already said what we're going to do. 2 pi divided by, what's my b value? 1/4, because this is like 1/4 x right here. Okay? So you divide that by 1/4, which is really multiplying by 4. So what's our period? 8 pi. Okay? Where's our new midline? The graph's just not going to go above and below the x-axis now. Y equals 2. Y equals 2 is our new midline. And what is our phase shift? If you don't remember the formula, you can always find the phase shift by doing what? Set parentheses equal to 0. But if you remember the formula, it's the opposite of C over B. I don't care how you do it. Okay? X over 4 minus pi equals 0. Add pi. So x over 4 would equal pi. Times both sides by 4, so 4 pi. 4 pi is my phase shift. 4 pi is how far I'm going to shift everything to the right. okay, because this is a positive number. What you get for your phase shift tells you exactly how far to shift it to the left or right. It's not, don't think of it as opposite, because you've done the work already for the opposite, all right? This was negative right here, so it does mean it's going to be a right shift. How far of a right shift? 4 pi, Derek.
So if that was positive pi, you'd shift it to the left.
If this said plus pi, I know for sure there's a left shift.
Okay.
Yep. How far? Just figure out the phase shift. That tells you how far to shift it in that direction. Go ahead.
So, will like the C value more than likely always be pi?
A lot of times it'll be something
So
like pi over 2, yeah, pi over 4. It's going to be something to do with radians because usually we're counting by.
Yeah.
Yep. I mean, it could be something different. That would make it a little bit complicated, but the ones I'm going to give you are going to, for the most part, have pi.
How would we graph it on something smaller like this?
Okay, so this would be the most challenging graph you'll have on a test right here. Okay, so I guess why not? I mean, and you will have one like this. They're not all like this. Some of them are very simple. They don't have all these things put together into one. But I guess if we can do this one, then we can do them all, right? Okay. So, if I were going to do this one, let me show you the table of value method. I think a lot of you will like this. Okay? So we're working with cosine, right? So I would say start with your cosine table. So 0, 1, pi over 2, 0, pi, -1, 3 pi over 2, 0, 2 pi, we're back to 1. That would be my regular cosine graph, right?
Yep.
If you don't like the table method, that's fine. There is a lot to keep track of without using a table. You can do it. I usually do it that way, and you guys can too. But it is a lot to keep track of. And so sometimes the table is beneficial. So this is just your regular cosine graph. Okay? All right, well, did we have a change in our amplitude? Okay, what was our A value? -3. So what could I do to all of these Y values? Multiply them by -3. And did we have a change in the period? The period became 8 pi, right? So if the period became 8 pi, what did we do to all of the x values then to change them? Divide by 1/4 or multiply by 4, right? Okay, so this became 8 pi. This is still 0. If I multiply this by 4, what do you get? If I multiply this by 4, 2 pi, 4 pi, 6 pi. Okay? Do your amplitude and period first. Okay? Do your amplitude and period first. What does the new midline affect? The x or the y values? Yeah, that +2 at the end, isn't that going to add 2 to all your y values? So what I would do back here now is I would do the d value, if you will, or the new midline. What do you think I need to do to all those y values? Add 2, because didn't it say +2 at the tail end? So I'm just going to add 2 to all those values. So -1, 2, 5, 2, -1. Okay. What does the phase shift affect, the x or the y values? It moves it left to right, so it's affecting these x values right here, okay? So because my phase shift was 4 pi, that's going to move everything to the right 4 pi, or I'm going to add 4 pi to all my x values. So right here in my phase shift, I just need to take all these x values and add 4 pi to it. So 4 pi, 6 pi, 8 pi, 10 pi, 12 pi. So what coordinates now, if I want to just graph one period worth, what's the first coordinate I'm going to plot?
4 pi.
4 pi, comma, negative 1. Okay? My new midline went up too, right? I like drawing in my new midline with a little dashed line. And to go back, it looks like I could count by 2 pi. Would that make sense to count by 2 pi on the x-axis?
Yeah.
Okay, stay with me here. I need to get all the way to 12 pi, 2, 4, 6, 8, 10, 12. I got room. 2 pi, 4 pi, 6 pi, 2 pi, 8 pi, 12 pi. And I'm just counting by ones here. So 4 pi, negative 1, 4 pi, negative 1. 6 pi, 2. 8 pi is 5. 10 pi, I'm back to 2. And 12 pi, I'm back to negative 1. Is that one period's worth? Okay. If I said graph 2 periods worth, could you do it by following the pattern? You could. I'd probably, because I'm running out of room there, I'd probably see if I could fit it over here. But you could graph another period of it without having to make another table of values, correct?
Yes.
By following the pattern, because what's it going to be at 2 pi? Back up here at 2, right? It's going to be back on the midline. How about at 0? It'll be up here at 5. So I mean, if I wanted to graph more of it, I certainly could. Okay? Does it look like your midline is at y equals 2? Okay? Does it... the midline is y equal 2. Does the amplitude look as though it's 3? Is the height of the wave 3 units? Here's your midline, 1, 2, yep, it gets up to 3 there. Is the period 8 pi? Does it take 8 pi to complete one wavelength? See how I'm checking my work here? I'm making sure that that matches everything. Okay? So, that's pretty much as complicated as they will get. Questions?